This video introduces writing your own functions in C++. So the big idea of functions, remember, is to provide reuse of code and abstractions. If I wanted to calculate 10 to the 4th power, I could write a little loop to multiply 10 times itself 4 times. That would work. It doesn't work for negatives. It's pretty ugly. I can't really tell what's going on here unless I stop and think about it. And then anytime I want to raise a number to power, I'd have to copy and paste this code. That's a horrible idea. Instead, what we want is to write this function once well that handles negatives and fractional powers and all that other good stuff, and then reuse that. And I'd like to replace this mess with just pow 10, 4, right? Make my code more legible. So that's what we're seeking to do with functions, to build our own functions that replace blocks of code instead of copying and pasting them all over, replace those with abstractions that we can easily reuse. Remember that a function has a header, the contract that establishes what information goes in, the parameters, what information comes out, and what the name of the function is. Well, to declare and implement a function, you need to have that header, that prototype, and then you need to have the body of the function, a block of statements that's going to actually execute the function, going to do the work that takes in the parameters, transforms them, and returns an answer. All right, so what this might look like is, here's a function called max. It takes in two integers, num1 and num2, separated with a comma. It returns an integer. That's the promise. You give it two integers, it returns an integer back. And max tells us that else is probably going to be the larger of the two. Now, the curly braces, this is where the code is actually implemented. And that can be start on the next line, or the start curly brace can be on the same line as the header. Either one's fine. The other piece we've got inside this body is, so we've got some code that's going to work with num1 and num2. But then at the end, we've got this return. And this is the part that's going to take our result, our integer that we calculate, and give it back to fulfill this part of the promise, that we're going to give you back this answer. Now, once I've created this function, I can make use of it somewhere else in my code by saying, oh, just go do the max thing and pass in these two numbers, I and j. In this case, they have 5 and 2 in them. And I want to see what happens. So we're going to switch over to the code for a second. Here's that same code in my max function, and we're got a breakpoint right here. Important to note that your program always starts at main. It doesn't matter that max is up here. Your program automatically starts at main. So we'll set I, we'll set j, and then we'll do this line. So I've got a breakpoint. I'm going to start it up. Let's stop right there. Let's see, I is 5, j is 2. We're about to do max and store the result into k. So now with functions, these two buttons, step over and step into, do different things. If I step over the function, it just does the whole line and tells me, oh, k is now 5. If I want to see what happens inside the function, so I need to stop the debugger, restart it, I need to step into it. So if I step into the function, we're going to go from out here where I and j are, past those values, 5 and 2, into the max function, and you'll see what actually happens is we bounce up there. So we'll step into the function, and so now we're inside max and we're going to execute this code. 5 and 2 are the two numbers we passed in. We're going to calculate the result, so I'll step a little bit, figure out what the result is, and now we're ready to return the result back out. Alright, going back to the kind of theory for a second, we have to declare this function before we try and use it. Later on we'll learn ways to kind of relax that restriction, but for now you have to tell the compiler all about the max function before you're allowed to use it. Right? When you say max here, it needs to know exactly what you're talking about. Other kind of rules about how functions work: the function name, like any other name, it should be one word. You can't have spaces, you can't start with a number or anything else weird. Use camel case to build up function names, so smash together words and make each additional word uppercase is one convention. Another convention uses underscores to separate words, but the book and I prefer camel case. Focus on clearly readable function names. Verbs are usually a good idea to describe what action is happening, but make sure your function name is descriptive, not terse. The body of the function, right? This is where the magic happens. It's always a block of code inside parentheses. You can't omit that, the curly braces for a function body. And anything that's happening inside here only exists inside this function. We'll talk more about this in a second, but any variables you have are only exist inside the scope of this function. The parameters that you declare essentially are special variables that only exist inside this function as well. And like I said, you can have as many parameters as you want. You can have int number, comma, double x, comma, double y, comma, as many things as you want. It's even okay to have no parameters. But what these provide for you is a way to get information from outside the function to inside the function. Right? I want to work with num1 and num2 inside the function. I'm going to pass those in from outside the function using the parameters. That's how we get information into the function. Once I pass that information in, it's stored in this new variable that only exists inside there. Now, this idea of scope for a function, it means that you can't use variables from outside the function on the inside. I and j exist in main. I cannot use those in my max function. And I can see that in the debugger. There is no I and j right now. Those don't exist. They are things from out in main. Out in main, so I can go look at what the world looks like in main, there's I, j, and k, but there's no num1 and num2 or result. Right? These are the only things that exist in main. So we have different sets of variables in different places. The way I get information from one place to another is passing it in via those parameters. And what we can end up with is this, what's called a call stack. I started in main, I called max, maybe max calls some other function, and we can build up this big stack of function calls. And when we're done with a particular function, so I'm done with the max function, we bounce back out to main, and we return our result back out. Once again, we can see this in the debugger. So right now I'm looking at, here's where I am. I'm in the max function on line 14. How I got into max function is I was on the main function, line 22. So this area, which you probably haven't looked at before a whole lot in the debugger, is going to show you your call stack, the function list that got you to where you are. And the top is where you are. And if there's, if you called main called max, which called some other function, then you'd have a longer list of here for your call stack. But so I can go look at what the world looked like in main. I can look at what it looks like in max currently. And once I'm done in max here and I return my answer back out, so result is 5 and we return that back out, we hit the end of the function. Now you can see the call stack is back to just being main. That's all there is. We're done with max. Essentially, we've completely forgotten about it. We built up this chunk of memory to hold the information for max, and now it's gone. So, moral of the story is inside a function, the only information you have available are the parameters you pass in and any new variable that you declare. The way to get information out of the function is the return statement. That is how we fulfill the contract. So, this is a contract. Absolute value function ABS takes in a number, returns an integer. I better return an integer. In this case, I'm returning number, which is of type integer. And so I'm fulfilling that contract. It's okay to return from wherever you want. As soon as we hit a return statement, we'll automatically bounce to the end of the function and leave it. But you have to be careful that every possible path through your code returns an answer. So I could write my absolute value function. Here's one way. I have number. If it's less than 0, I negate it, and then I return the number. This is probably the best way to write that function. I could write a separate return from the else and the if. A little ugly to repeat the code, but I could do it, and that would work fine. But when you start doing that, you start returning from all kinds of crazy places, it's easy to miss a location where you should return from. So if I come into this version of the function and number is negative, we'll negate it. and then we'll skip the else, and we'll get down here, and I never return anything. And I get this warning, control reaches end of non-void function. It's trying to tell me, hey, you never return any information. So basically what's going to happen is just some random gibberish is going to come back. I may get lucky, it may be what I happen to want to be returning, but there's a good chance it's not going to be. It's just going to be some nonsense information. So we have to make sure that we always return information. Now, it may be the case that you don't want to return anything. Print as money function takes in a double, and it just prints out a double so it looks like money. 2 decimal places with a $sign in front of it. This function does some work. I don't need an answer from it. So the correct type for that is a void function. When you say void is the return type, you say it actually doesn't return anything. It just does some work, and then it'll come back to you. So when we hit the end of a void function, we bounce back to where we were in the code, and we keep going. But we don't get an answer back. So the void function, there's no contract of something to return, so I don't even need a return statement. If you want, you can say return semicolon with nothing, but you can also just fall off the end of the function and automatically return. One or two other ideas and pieces of advice. The first is something you should not do. A global variable. So I've said that every variable has its own scope, or every function, has its own scope, its own set of variables. If you make a variable outside all your functions, like int y gets set to be 100 up at the top of your file, that's available in every function. That is a horrible, horrible idea. It's one way you can share information between different functions, but it makes for really hard to debug code when there's just mystery pieces of information that everyone's touching and modifying and looking at. You get just this messy, ugly code. So a class rule, you are not allowed to use global variables. If you do it on assignment, expect a massive penalty. The only thing that's permissible to do at the global scope is to declare a constant. At the top of your file, it's fine to say constant int pi equals constant double pi equals 3.14, and so that everywhere you can just use pi. And that's safe because you can't change a constant. But when you have variables that are getting changed all over at the global scope, that's when you get into problems. The way you should be communicating information from one function to another is using your parameters to get information in and using the return to get information out. That is a nice, clearly defined channel of communication that makes it really easy to track how information is propagating through your program. Other tip is, in general, functions should not be using the console. A max function that's supposed to take in two numbers and return the larger one, what that means is it takes in these parameters. It gets its input from those parameters, not from the keyboard. If we read in stuff from the keyboard, we ignored the values that some other code just tried to pass in. We threw out the I and j values and we replaced them with new stuff. Similarly, when you get done and you're ready, you've got your answer ready, you return it back. You don't just print it out. And this is because we may not want to print that answer, right? We may want to send that, put that answer into a database. We want to use that to do some more calculations before we print something out. By printing out the answer inside your function, you're limiting this function to just print out the max, not get me the max so I can do other work. The only exception to this rule is if the function's whole purpose is to do input or output. Right? Get balance from user function. Its job is going to be to ask the user for the bank balance, read it in, and return it. That would be a fine exception to this rule. Print as money. The whole point of this function is to print something out so it looks like money. That would be an okay place to use cout. But in general, if you're writing a function, you should not be using cout or cin unless that's the express purpose of this function. One last piece of advice is, in general, so now I've got this distinction between things that print things versus just return information. To make it real clear why I'm saying the returning is better, here are two versions of getGrade, right, that both are going to turn a score, a numeric score like 92% into something like the character A. If I have a void function that just prints out the answer, wonderful, I can use that to print out the score, but that's all I can do with it. If I have a function that returns the character A instead of just printing it out, then I can choose what to do with it. I could print that out myself, or I could get that character and I could get a character for the next test and the next test and then print them out so that they're formatted in a specific way. Right, I've got more control over exactly what's happening. Or I could take that A and convert it into 4 grade points to calculate GPA. Right, I've got much more flexibility about how I use it. So focus on functions that take in information via parameters, return it back out, handle most printing and input out at the level of main.